Good morning or good afternoon. Welcome back, and today we're going to talk about Pythagorean Theorem, Pythagorean Triples, and Pythagorean Converse. Now, you probably have heard of Pythagorean Theorem before. It's a squared plus b squared equals c squared, where c is the hypotenuse of our triangle. Now, c is the hypotenuse. It should always be the biggest number. So a and b are your legs, and it doesn't matter which one is which. So remember, the legs make that L, they make that could be A, that could be B, or you could have that be B and that be A. Either way, it doesn't matter as long as C is your hypotenuse. So if we just jump on in with this first problem, asking yourself, are you missing a leg? So are you missing A or B, or are you missing C, the hypotenuse? Well, I have nothing, so I'm going to label my hypotenuse as C. That's what I'm missing, which makes my legs A and B. And remember, A and B are interchangeable. It really doesn't matter. So Pythagorean Theorem, a squared plus b squared equals c squared. Now I'm just going to plug in my numbers, and the calculator is going to do most of the work for me. So 2.7 squared plus 6.5 squared equals c squared. Now you do have to be careful and type it in exactly like that into the calculator. And if you type it in just like that, you get 49.54 equals c squared. But we're just wanting c. We just want the hypotenuse, not c squared. Also think about it. 49.54 for the hypotenuse is way too big, considering our sides are 2.7 and 6.5. So the last step is to square root it, which is this symbol right here. And if you look for your calculator, that symbol is right above x squared. So to access it, you can do second x squared, type in your number, and we get that c is about 7.038. Let's round that to 7.04. So if it's 7.038, the 8 would make the 3 go up to a 4. And I'm using that squiggle because that means approximately. Because my answer is not really 7.04, it was really 7.038465742, but I'm going to go ahead and round that. So taking a look at the next one, asking ourselves what's missing. And if I go to label it, remember that C is always across from the box. So I have my hypotenuse, it's just one of the legs that I'm missing. And it doesn't matter which one is which. So I'm going to label that one A and label that one B. And now I'm going to go back to my formula. So a squared plus b squared equals c squared. And I don't know a, so a squared plus 2.7 squared equals 6.5 squared. So now I'm just going to go to the calculator and figure out what is 2.7 squared and what's 6.5 squared. I'm having some decimals, that's okay. And now that I'm here and I'm looking for a leg, I need to be careful because on the last one I was adding. So I was squaring each value and adding them together and then square rooting. But now if I'm trying to get a by itself and I'm looking for a leg, what you're going to end up doing is subtracting. So if I subtract those values, I get that a squared equals 34.96. Now, I know that can't be the length of the leg because the leg can't be 34.96, which is longer than the hypotenuse 6.5. So if we square root that answer, we get about 5.91. So make sure that you know where that square root key is on the calculator. It's going to be very difficult to do this without it. So taking a look at a word problem, the length of a diagonal of a television screen is 42 inches. If you did not know this, they actually use the diagonal as like a sales trick because the diagonal is the longest part. It's longer than the legs. It's longer than the length or the width. So they use the diagonal, and they do this for cell phones as well to trick you into thinking you're getting something bigger than it is. So if I have a TV screen, the length of the diagonal is 42 inches. And the length of the bottom of the screen is 36 inches to the nearest tenth. So they told us what to round to. If they don't tell you what to round to, you can kind of decide. But they told us to the nearest tenth. So if they tell you we got to use that, What is the height of the television screen? So there's my x. Well, right here I have a right triangle, so I'm going to go ahead and put that box in there. And if I have a right triangle and I know two sides and I'm missing one, that's when this Pythagorean theorem comes into place. It helps me find that missing side. So a squared plus b squared equals c squared. And if we ask ourselves what's missing, well, I know that my hypotenuse is 42, so there's the c. So then it doesn't matter. You can make that piece b and make that piece a. So then I would say 36 squared plus b squared equals 42 squared. Okay, now because I'm missing a leg, if I go back up, if I know two sides and it's the hypotenuse, I'm going to add them and then square root. But if it's a leg that I'm missing, I end up subtracting. So when I go back to this and I find out what 36 squared is, and I'm going to have some big numbers, that's okay. So that's 1,296 plus b squared equals 42 squared, 1,764. Now I'm going to subtract them. So whenever I subtract, you should get, I'll give you a minute to subtract in the calculator. You should get that b squared is 468. Okay, now that's not the answer, that's b squared. So if you go ahead and square root it, I'm going to give you a minute to square root it. And then think, what would that be rounded to the nearest tenth? That's one decimal place. And if you do it correctly, you should get 21.6 inches. So I would say this is a very weird TV if we think about it. I mean, it's 36, it's 3 feet wide, and it's 21.6. So it's literally 3 feet wide, and it's not even 2 feet tall. So this is a very, very weird shaped television, but that's okay. We're not buying it. Now, this next one, it says a 39-foot ladder. Ladder problems are so common in this unit because if you have a ladder resting against a wall, so let's say that this is the brick part of our house. Let's say here's the grass along the edge of the house. Well, if you have a ladder that's resting up against the wall, doesn't your ladder make a triangle? It does. So you have your house, the ground, and then the ladder resting against the wall, and it ends up making a right triangle, to be specific. So back to this problem, a 39-foot ladder rests against a wall. So 39 foot, that's the ladder. It's leaning against the wall. That's my hypotenuse. So 39 should be the biggest number. And then it says that the base of the ladder is 15 feet from the wall. The base, the bottom, is 15 feet. How high is the ladder? There's my x. So we're missing a leg. We know the hypotenuse. So if I go through A, B, C, so a squared plus b squared equals c squared. I'm going to give you a minute to see if you can figure this one out and see if you can figure out how high that ladder is. So if I go through a squared plus 15 squared equals 39 squared, so then a squared plus 225 would equal 1,521. I'm going to go ahead and subtract them. So a squared equaled 1,296. And then when I go to square root that, I don't get a decimal at all. I actually get 36 feet. So in this triangle, I didn't have any decimals. So if I go back, this one I had 2 whole numbers and a decimal. This one I had 3 decimals. So decimals, this one there are no decimals at all. It was 15, this side was 36, and that's 39, which leads us into Pythagorean triples. Now, you may remember Pythagorean triples from a few days ago when we talked about need to know things for this unit. A Pythagorean triple is just a whole number that fits a squared plus b squared equals c squared. Now, keep in mind that you can always use Pythagorean Theorem. So if you don't know these triples, it's okay because you can use Pythagorean Theorem. But if you know the triples, you'll start to see them again and again and again, and they make your life easier. So our base triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Now, there's some silly YouTube videos of people singing all sorts of songs over the Pythagorean triples, but the two main ones to remember are 3, 4, 5, and 5, 12, 13. Now, the way that these triples work is that they work and then their multiples work. So like 3, 4, 5 times 2 is 6, 8, 10. That's pretty popular. 3, 4, 5 times 10 would be 30, 40, 50. 5, 12, 13 times 2 would be 10, 24, 26. And notice that the biggest number is always going to be your hypotenuse. So if you see 3 and 4 on the legs, 5 has to be the hypotenuse. That's how these triples work. So if you know the triple, it makes your life easier. So let's take a look down just at this one right here. I could do Pythagorean Theorem if I wanted, but if I see 30 and I see 50 on the hypotenuse and I remember 3, 4, 5, all this is done is just add a 0. So 3, 4, 5, so 30, 40, 50. That's it. It's a 3, 4, 5 with a scale factor, which means it was just multiplied by 10. So let's go back and take a look at this first one. So 9 and 12, if I told you that it was a 3, 4, 5, giving you a clue, ask yourself, what would be the scale factor? Well, 9 and 12 have 3 in common, so 3 times 3 is 9, and 4 times 3 is 12. So I have the 3 and I have the 4 with a scale factor of 3. 5 times 3 would be 15. Now, Pythagorean triples are really hit or miss. Some students get it and they love it and they recognize these patterns. Some students don't get it and they don't love it and they go back to Pythagorean Theorem every single time. That's fine. You can do Pythagorean Theorem every single time, but sometimes knowing your triples is a little bit easier. Like on this one, I see 3 tenths, 5 tenths, 3, 4, 5. Well, if I continue that pattern, the last side would just be 4 tenths. It's a 3, 4, 5 divided by 10. And if I take a look at this last one, if you know that 36 and 48 have a number in common, and that's 12, well, 36 divided by 12 is 3. 48 divided by 12 is 4. So I have a 3, 4, 5 with a scale factor of 12. Well, 3, 4, 5, 5 times 12 would be 60. And that's how Pythagorean triples work. Remember that, once again, I just want to clarify, you can always do Pythagorean Theorem, but the Pythagorean triples will sometimes save you some steps. So we're used to using Pythagorean Theorem whenever we're trying to find a side, but Pythagorean Theorem Converse will actually tell you what type of triangle it is. So if you have 3 links and they can actually form a triangle, that's the big catch. If A plus B is greater than C, they have to actually make a triangle. If we do that first, then second, you can use Pythagorean Theorem Converse. Now remember that converse means flip, which is why that c squared is now at the front of our formula. And if c squared is equal to a squared plus b squared, then I know it's a right triangle. If c squared is less than a squared plus b squared, so after I flip it, so I put c squared first, then I know it's an acute triangle. And if c squared is greater than a squared plus b squared, then I know it's an obtuse triangle. So the way that this works is I can use Pythagorean Converse to classify a triangle if I know all the sides. But first we want to check to see if it actually makes a triangle. So taking a look at our first one, part A says determine if they can even make a triangle. So I'm going to do a quick check. So remember, I'm going to add my 2 smaller sides. So 20 and 21 would be 41, which is greater than 28. So yes, it does make a triangle. Okay. Now I'm going to classify it with Pythagorean Theorem Converse. So c squared goes first. So now I'm doing part B. How does c squared compare to a squared plus b squared? And that's what I'm going to find out. So c is always the biggest one. So how does 28 squared compare to 20 squared plus 21 squared? And you're going to go type all this into the calculator. So 28 squared is 784. 20 squared plus 21 squared should be about 841, my bad. So 20 squared plus 21 squared is 841. Well, 784 is less than that, which would make this, yes, a triangle, but if c squared is less than a squared plus b squared, it's an acute triangle. That's how this works. So let's take a look at our next one. And if we check the square root of 13 in the calculator, it's about 3.6. It's about 3.6. So if it's about 3.6, and I just want to know, do they even make a triangle? Well, 3.6 and 10 would be 13.6, which is greater than 12. So yes, I can carry on. They make a triangle. So now to classify that triangle, I'm going to see how does c squared compare to a squared plus b squared. So c squared is 12, that's the biggest one. How does that compare to the square root of 13 squared plus 10 squared? Now, you don't need a calculator for this one. 12 squared is 12 times 12. You probably know 12 times 12, that's 144. How does that compare to? Well, the square root of 13 squared is just going to be 13. The square root and the squared cancel each other out. So that's 13. Square root squared cancel out. 13 plus 10 times 10 is 100. Well, how does 144 compare to 13 plus 100? Well, it's bigger, which would make this, yes, a triangle, but an obtuse triangle. So taking a look at this last one, the square root of 82 is about 9.1-ish, and the square root of 87 is about 9.3-ish in the calculator. Either way, let's pretend that it's 9 and 9. When I go to check this in the calculator, 9 plus 9 would be 18, or 18.4, which is going to be greater than 13. So yes, it makes a triangle. So now let's flip it around. So how does c squared compare to a squared plus b squared? Okay, and I'm going to give you a minute to do this one. Remember that you don't need a calculator to square those. So see if you can figure this one out on your own. So c squared was 13 squared. How does that compare to the square root of 82 squared plus the square root of 87 squared? So 13 squared is 169. And then the square root of 82, that's just 82 plus 87. And if you add those together, we get 169 and 169, which are equal, which makes this a right triangle. Now, my question to you is, this is a right triangle, but was this a Pythagorean triple? Well, Pythagorean triples are whole numbers, and those weren't, so it's not a triple. So let's take a look at one more. I'm going to give you these side lengths. I'm going to give you 1, 2, 3. So I want to know what type of triangle is it. So follow that same process, and I want you to check right now 1, 2, and 3. Take a minute. And hopefully you were able to figure out that I was trying to trick you there, because if you add 1 and 2, is 3 greater than 3? No, which means that it doesn't make a triangle, which means that I can't go on to this second step of Pythagorean converse. So be really careful with those ones. Hopefully you learned some new takeaways today. You were probably familiar with Pythagorean theorem, but hopefully you learned more about Pythagorean triples and Pythagorean converse.